class, in this video, I'm going to talk about regression analysis, and in particular, we're going to do linear regression in this video. All right, so I want to start off with what we call scatter diagrams, or sometimes we call it the scatter plot and correlation. So a scatter diagram is a graph that shows the relationship between two quantitative variables. And when we say quantitative, it means you can measure it by a number. So the data set is represented by points. So in Unit 1, when you studied about linear equations, for example, we know that each point is represented by two numbers, your x-coordinate and your y-coordinate. So in this example, suppose I have a year here, right? And then I have the price of a handbag. So it's the same handbag, obviously. So for 2009, it costs, the price of it is $245. And then as you can see, it goes upwards, right? As time goes on. So using Microsoft Excel, I was able to create what we call a scatter diagram or a scatter plot, which you can see here. So as you can see, each pair here is represented by a point. So for example, this point right here is for the year 2009, and the price of that is $245. And I would plot all the points until 2014. So we say positive correlation between the variables, and the reason for this is because as the time increases, the price also increases. So they go up at the same time. So examples of variables that are positively associated are number of years of working experience and salary, for example. Because as the number of years of your working experience increases, usually your salary also increases. Another example would be the number of followers and social media income, right? So usually, not all the time, the more followers you have, the higher your social media income is. How about you? Can you think of a few examples of two variables that are positively associated, right? So meaning if one variable increases, the other variable also increases. So I have here another set of data wherein I have X will be the price of a handbag, and then Y will be the sales rate, right? So this time when I draw a scatter plot of the data, you can see it here. If I were to draw a line that traces the points, it would be a decreasing line. I hope you can see that. So let's look at my cursor, right? So this is my first point. So as the price increases, right, the sales rate now goes down, right? So in this case, this data set is negatively associated because as the price increases, the sales rate decreases. So examples of variables that are, sorry about this, negatively associated, all right, would be the number of hours of exercise and your weight. Usually, the more you exercise, the lower the weight is going to be, right? So they are negatively associated. Another amount would be amount of spending and savings. So the more you spend, right, the savings will go down, right? So how about you? Can you think of two examples or two variables that are negatively associated? All right, so another thing when it comes to regression that we are interested in is what we call your correlation coefficient, or in this case, since we're doing linear regression, it's linear correlation coefficient, and we denote that by a small letter r. So this value is a measure of strength and direction of the linear relationship between two quantitative variables, so variables that you can represent by a number. So here are some properties of the coefficient r, right? So r is between -1 and 1, right? So the values cannot be 2 or it cannot be -2, right? It stops at -1, it ends at +1. Sometimes if we write it in percent form, it will be -100% all the way to 100%. And if r is equal to 1 or equal to 100%, then we say that there is a perfect positive linear relation between the two variables. On the other hand, if r is -1 or -100%, then we say that there's a perfect negative relation between the two variables. Now, the closer the r, or the linear correlation coefficient, to 1, the stronger the evidence of positive association between two variables. So for example, if your r is equal to 95% or 99%, the stronger the association is. Similarly, if r is close to -1, right, it's also a strong correlation or strong association, but we say it's a negative association. And finally, if r is close to 0, for example, 5% or -2%, then there is little or no evidence of linear relationship between the two variables. All right, so now let's take a look at the graph. So in the beginning, I just showed you a scatter plot, meaning all the points that I have graphed. So now, as you can see, we are going to draw a line, right, that best fits those points. So if we take a look at graph A, we say there is a positive correlation, and the reason for that is your line is increasing. So that's equivalent to saying that the slope of the line is also positive. Now, on the other hand, if you take a look at graph B, right? So now I drew a line that best fits my data. So this one, we say that there's a negative correlation between the two variables. And the reason for that is the line goes down, right? So we know also from Unit 1, when we studied linear equations, that the slope of the line here is a negative number. Now this one, you have a horizontal line, so the slope of a horizontal line is equal to 0. So here we say there's 0 correlation between the two variables. Similarly, for letter A, we can say that there's a strong evidence of positive association between the two variables, or positive correlation between the two variables. For letter B, we can say that there's a strong evidence of negative association between the two variables. For the third one, we can say there's little to no evidence of linear relationship. Now, if you take a look at this one right here, the points are sparse, right? So sparse meaning they are not crumpled together, or they are all over the place. So in this example, we say there's a weak negative association between the two variables. And why is it negative? Because if I were to draw a line, right, that best fits my points, it will be going down. And finally, if you take a look at this is even more sparse than the previous one. In fact, we cannot even know what the line is going to be. Is it a line that's going down? Is it a line that's going up, right? So in this case, there's a weak association between two variables, and we cannot recognize a pattern. Okay, so from the previous slide, as you can see, we drew these lines right here. So our next goal is now to find the equation of those lines. And we call that your least square lines. So we are interested in scatter plots that show a linear pattern. And if we think that the points show a linear relationship, we would like to draw a line on that scatter plot. And the line can be calculated through a process called linear regression. So this is very common in statistics. And why are we studying this if our topic is mathematical modeling or business modeling, right? So we can use a regression line to predict the variable y given a value of x, right? So that's the concept of mathematical modeling, what will happen in the future, right? So typically, you have a set of data whose scatter plot appears to fit a straight line. And this is called, as I've said in the previous slide, line of best fit, or your least square line. All right, so now let's go back to my previous data about the price of a handbag. So I have created here a scatter plot. So as you can see here, right, we said that there's a positive correlation or positive association between the two variables, because if you take a look at this, if I trace my points, I now have an increasing line. Now for the sales rate, right, if I were to draw a line that best fits the data, right, so now this is going down. So our goal now is to figure out what the equation is of these two lines. So now this is very easy to do on Microsoft Excel. The first thing you have to do is to type your data and then you highlight it, right? So like so. And then the second step is to click the Insert tab. So as you can see here, Insert tab. And what's nice about my version of Microsoft Excel is it tells me what kind of graphs I have, right? So please don't worry if your version of Excel doesn't specifically say, hey, this is a column graph or this is a line graph. What you can do is you just look for a graph whose icon is the one that has these points right here, right? So that would be your scatter plot. All right, so I will choose this one right here, right? So this is what I'm going to choose, not this, not this, not this, right? So I have a drop-down menu here that allows me to choose the design of the scatter plot that I'm going to create. Now, when the graph comes out, you would right-click on one of the points, as you can see from the picture below, right? So, well, if you're using Apple, right, or Mac, right, you don't have a right-click, you would just click maybe on one of the points, and you are going to look for this one right here, right? And what you would want to do is to click this one, the one that says Add Trend Line, all right? So you don't click anywhere outside your graph. You have to specifically click on one of the points, right? Not outside, not there, but one of the points. All right, so after you click Add Trend Line, then you would choose Linear, right? So this will be your options. Since we're doing linear regression, this is what you're going to click. You would also want to choose to display the equation on chart because you would want to know what the equation is. And you will also display your R-squared or the I will explain later on what R-squared means, right? So you would want to display these two values, all right? And then once you're done, your graph will come out like so, all right? So you have your equation and you have your R-squared right here. So now let's explain what we're trying to do. What does it mean? So from the graph, the least square line is y equals 53x minus 106,255. X here, which is your x-axis, as you can see here, right, will be the years, and then y will be the price of the handbag. All right. So we also have r-squared here, right? So r-squared. So instead of r, right? Remember that small letter r, the correlation coefficient. To get the r, all we have to do is get the square root of r squared. So currently your r squared here is displayed as 0.9673, right? So since the line is increasing, this means that the slope is positive, right? So r is also a positive number, the small letter r. So obviously if the line is decreasing, the value of r will be negative. So now using my calculator, I have to obviously indicate that my r is positive because of the increasing line. And using my calculator, it came out to 0.9835, or I can write it in percent, so 98.35% is my correlation coefficient. So we can say that there's a strong positive association or correlation between the year and the price of the handbag. Now, what is the point of doing all this, right? So again, this is all about prediction, right? Or estimation. Suppose we want to predict or estimate the price of the handbag in 2020, right? So going back to our equation, x is the year. What we want to know is the value of y. We want to predict that. So I will replace now this letter x here, right, by 2020, which is the year. So 53 times 2020 minus 106,255. So using your calculator, it comes out to $805. So the trend continues, right? The price will still go up when we get to 2020.